And after I visited his institute for 1 month, and I was really impressed by the activities of his groups. He submitted and published the papers, 8 papers on physical review at that year. It's amazing for my standards. So today he has a lot of cards to show us, but I picked up one for disorder of development. Thank you. Please start.
Thank you very much, Dr. Inoue, for this opportunity to once again come and visit this wonderful place. I've always enjoyed coming back to Japan, in particular to ETL, and interact with all of you. I think we have several collaborations going, which has been very exciting for my group, and I hope it will continue the same way. So I once again take this opportunity to thank you for giving this chance of being here once again. But somehow I end up always choosing winter to come, so I find it very cold. And this is my first seminar in life that's going to be captured by video. My feeling and reaction is sort of like they say when first time the Europeans went to Africa and they wanted to take pictures of the African people. The African people were running away because they thought their soul will be captured in the photograph and they'll die. I have the same reaction. But I'll avoid to run away and I'll continue to talk what I promised. Please feel free to stop me, either to ask question or to ask me to slow down. I have a tendency to talk very fast. Most of the Indians talk very fast, I'm sure you have seen, and I talk faster than them. So slow me down, let it be very informal, and don't hesitate to ask a question at any stage. What I'm going to discuss today is the effect of disorder in strongly correlated electron systems. And when I'm talking about strongly correlated electron systems, I specifically want to discuss transition metal compounds. We have been investigating this aspect for a long time. As you all know, this is of course theoretically an intractable, unsolved problem to create disorder and strong correlation, not here, and strong correlation simultaneously. We have fairly good theoretical approaches that work reasonably well when you have strong electron-electron interactions, and again in absence of disorder, or we have fairly good theoretical understanding of how to describe the system when there is no electron correlation, but there is strong or weak disorder. But when you have both these phenomena simultaneously existing in a system, it is an unsolved problem of condensed matter physics, one of the most outstanding unsolved problems. And therefore, of course, I don't hope to give you a solution to that problem, nor are we going to tackle the problem theoretically. Most of the time, we have approached this problem in order to understand various manifestations of these two phenomena coexisting by looking at electron spectroscopy. So I hope to show you many electron spectroscopic investigation of different systems in order to elucidate different manifestations of such disorder effects, because it does not give rise to one single effect, it can give rise to very wide spectrum of different properties, and I'm going to choose a few examples and show you such examples and try to tell you what it means. The typical systems that we have studied over the last 4 or 5 years are listed here, some of them. This is silver sulfide, doped with slight amount of excess silver. Depending on this disorder, silver that is disorder, you can have either an insulator to insulator transition or insulator to metal transition as a function of temperature. We published a paper on this, I think, beginning of last year. You can have TIO